Today we're going to be working on Lab 4B, and we'll have 2 days for this. It's not complicated. I'm just going to give you the rundown of how it works. So it says that you need 4 group members for this. You really don't. You can do this by yourself if you want. You can work with 1 or 2 group members. That's up to you. Here is what we're going to try to do. We're going to try to figure out if there is a connection between where an element is in the periodic table, its electron configuration, and something called charge. And we should remember that electrons are negative and protons are positive. So if you have an element like, for example, say hydrogen that has 1 proton in the nucleus, right? It's got an atomic number of 1, and 1 electron orbiting. If you remove that electron, you'll have an ion with a charge of +1. On the back of your periodic table is a list of ions, a list of elements with charges. What we're going to do today is try to figure out if there is a connection between charge and electron configuration. So the first thing you're going to want to do is click this link, because this will bring up, you're going to want to open up Adobe Flash. It's going to bring up this website. And what this does is it shows us the electron configuration for any element. All we have to do is click on it. So if I want to say find the electron configuration for hydrogen, I just click on it. We see that there is 1 electron in the 1s, and on top of that it shows us the electron configuration over here. It will do this for any element that we pick, even if we start getting bigger. Here's chlorine. We know that chlorine has 17 electrons, and that its electron configuration looks like this. It fills P5, and over here it has already written it for you in noble gas notation. We're only interested in the ending part here. Some of these elements are going to get kind of big, and they'll show you that they have electrons that are ending in D's, and some of them have electrons that are in F's. So let's take a look at what we're doing here. So you're going to try to find the electron configuration for all of these atomic numbers starting here. And so if you're group member 1, you'll do these 9. If you're group member 2, you'll do these 9, and so on and so forth. 3 and 4 only have 8, but their atomic numbers are a little bit bigger, so it averages out. Let's say that I am going to find the electron configuration for element number 1. Now there's a couple ways that you could do this. Over here I have listed a bunch of these orbital filling diagrams, and if you want to make more of them, they're really easy. You can just copy and paste them and stick another one in there, so you have as many as you want. There it goes. So you have as many as you want. There are 9 here. If you want to make more, you certainly can. So if the first element I'm doing is atomic number 1, it is, of course, hydrogen. This isn't really necessary, but you do want the symbol. And according to our helpful little chart guy here, the electron configuration for atomic number 1 is 1s1. So I'm going to record that here. I can either do it like this, or I can simply say that hydrogen has an electron configuration of 1s1. You're going to want to keep track of all of the atomic numbers that you are working on, because when we're done, we're going to collaborate with our group members, and we're going to try to answer the following types of questions. For example, find all the elements that end in S1. And there are going to be more than 1. Hydrogen is simply one of them. And it's also going to ask a couple questions. What column are they in? And of course, looking at our periodic table, we know that they are all in group 1, which is of course this first column here. And finally, what charge do they form? we're going to be referring to this list of ions that's also on the back of your periodic table. You should see that there is a commonality, and that all the elements in, for example, say group 1, which happen to be all elements that end with an electron configuration S1, have a tendency to form a charge of +1. That's our game plan here. We're going to be looking for elements that form a charge of +2, elements that form a charge of +3, or -1, or -2, or -3. We're going to be looking for elements that are in what we're going to call the D section of the periodic table. That's this middle section. We're also going to be looking for elements that are in the F section, and that's these 2 rows down here. We'll have 2 days for this. I'll be standing by if you have any questions. And let's remember that the Chapter 4 review is going to be Friday, October 9th. All right, best of luck, and that's all I have. So if you have any questions, let me know.